Do you ever wish you could hit more home runs?
Well, with some recent advancements in wood baseball bats, you could be hitting homers in no time. At the season opener of the 2025 Major League Baseball season, the New York Yankees hit a whopping 4 home runs in just the first inning using a new bat, the Torpedo bat. So, what makes this funny looking bat any different from the cool one we've been using for decades?
Well, it comes down to a few things. First, we have to consider the physics behind what happens during a ball-bat collision. Let's look at types of collisions. In elastic collisions, the objects respond similarly to objects on ice, like you might see in curling, where rocks collide, one transferring all of its kinetic energy to the other. This can occur when objects are completely rigid. Most of the collisions you see in everyday life, though, are inelastic collisions. During inelastic collisions, energy is lost, so not all of the energy is transferred to another object. Energy can be lost to heat, sound, and in the most notable case for the baseball example, vibration. Despite what you may think, wood baseball bats are not perfectly rigid. They can actually vibrate. You can feel this if you were to tap the baseball bat while holding it with one hand. But to achieve a scenario where less energy is lost, the bat has to be more rigid. The more rigid the bat is, the more of the bat's mass the ball experiences. It was found that when the torpedo bat was hit at the sweet spot, the spot where its diameter is largest, the mass that the ball experiences is closest to the mass that the ball would experience if the bat was completely rigid. Through this, we know that the torpedo bat is more rigid than the standard bat when hit at the sweet spot. When we see an event that includes a collision, we have to look at two things, impulse and momentum. Momentum can be found through the product of the mass of the object and the change in velocity of the object. And impulse can be found through the product of the force on another object and the time for which that force is applied, or the time for which the objects are in contact with each other. Now, through Newton's second law, we can derive that impulse and momentum are actually equivalent. By rearranging that equation, we get force times time divided by mass equals velocity. If the ball is hit with a constant force and a constant mass, the only variable is time. If the bat vibrates more, the collision occurs for less time than if the bat is completely rigid. In our equation, if time increases, so does velocity. So from all of this, we can see that by minimizing vibrations at the sweet spot, the torpedo bat gives the ball a higher exit velocity, making it easier for batters to hit home runs. But this only actually occurs if the batter can hit the ball at the exact right spot. Everywhere else on the bat, the standard bat is more effective. So in the world of pro baseball, the torpedo bat is effective because players at this level can consistently hit the ball at the sweet spot. Also, torpedo bats work with wood bats, but not necessarily the bats that most youth, college, or even softball players use. But with ongoing work from engineers, evidenced by the creation of the torpedo bat, soon you and every baseball and softball player will be able to hit more accurate bunts, faster ground balls, or even more home runs.